Hi and welcome back. So in this video we're going to do actually an ideal gas equation practice for the final exam or for our I guess I should say my final exam. So in this example we are given this information. We say that we have 0.678 grams of some gas, and that gas is occupying. Oh, looks okay. Oh, I'm getting the spinning wheel. So hopefully I hope you could still hear me through that. I just got the spinning wheel for a second, but anyway. So the problem is we are given this information. We have got 0.678 grams of some gas. And we know that that gas is occupying 450 milliliters of volume. And that 450 milliliters is at a pressure of 774 millimeters of mercury. And that this is going to be at 32 degrees centigrade. So what we are trying to figure out is what is going to be our molar mass. So this is the problem if you want to pause the video. So we have 0.678 grams of a gas, and it occupies 450 milliliters of volume at 774 millimeters of mercury, and at a temperature of 32 degrees Celsius. And we have to figure out what our molar mass is. So now let's remember our ideal gas equation. So we remember that it's the pressure times the volume is equal to the number of moles we have times our ideal gas constant R times the temperature. And always remember it's going to be the temperature in Kelvin. So now let's take a look at this N, because N is going to be our number of moles, right? And we can say that the number of moles, and we've figured out a number of times. I could give you a problem if I said, I have 1.50 grams of sulfur. How are you going to figure out how many moles of sulfur I had? If I told you I have 1.50 grams of sulfur, how would you figure that out? Well, you would take this mass that I gave you, 1.50, and you would divide that by the molar mass. And let me see, I can't remember what the molar mass of sulfur is. So 32.065, and that doesn't necessarily matter. 32.065 grams per mole. But we would divide that. We would divide 1.50 grams by 32.065 grams, and we would get how many moles we would have. So in other words, let me actually just write that as to say that the number of moles we have, which is the same thing as N in our ideal gas equation, so the number of moles that we have is going to be equal to the mass divided by our molar mass. Okay? So let's actually just rewrite that into this equation. So instead of saying N, let's write our mass in grams over our molar mass in grams. So our new ideal gas equation, or this new version of the ideal gas equation, is going to be PV is equal to our mass divided by our molar mass times the ideal gas constant R times the temperature in Kelvin. So now we really know, if we take a look at this problem again, we really know everything we need to know. We know the volume, so let's actually check off everything. So we know the volume, we know the mass, so we know the mass, we know the pressure. R, we know what R is. R is going to be our ideal gas constant. And we know the temperature. So we just have to solve for our molar mass. So let's actually just algebraically solve for that. And I can do this really quick, that molar mass we would multiply. So let's actually just do this. So we would get molar mass times pressure times volume is equal to mass times R times T. And then to just solve for molar mass, we would say molar mass is equal to our mass times R times T, put those in parentheses, over PV. Okay? So let's do, actually I guess I've got enough room over here. And actually, you know what? I'm going to start erasing some stuff just so I've got a little bit more room to work with. There we go. Start erasing. Sorry, took me. There we go. Just take me a second to erase all this. Erasing. Okay, there we go. So now I've got enough room to work. Or we've got enough room to work, I guess. And so we're solving for the molar mass. So let's first put in our mass. Our mass is going to be 0.678 grams. And we're multiplying that by our ideal gas constant R, which is going to be, if you remember, R is going to be, let me give ourselves a little bit more room this way. It's going to be 0.08206, and I'll leave the units out off of this for right now. If you want to see what the units are, you can look further back in the playlist where I go through all the ideal gas constant stuff. So we're going to use this constant R, 0.08206, and then multiply that times the temperature. And remember, we were given the temperature in centigrade, right? And what do we have to do to get this into Kelvin? Well, we have to take 32 and we have to add 273, right? So let's figure out what this would be. There 273 plus 32, so that would give us 305, right? Yeah, 305. 305, so we're going to multiply that. I'll just arbitrarily keep switching colors, times 305. And then we're going to be dividing by, I'll do the volume first. So we're dividing by, and remember, our volume is going to be in liters, right? So let's actually just rewrite this as 0.450 liters instead of milliliters, or I could have done a conversion factor here, but I decided to just go ahead and write this as 0.450 liters. And now for our pressure, remember that for our ideal gas constant that we're using here, for us to be able to use 0.08206 as our R, we have to have pressure in atmospheres. And right now we're given pressure in millimeters of mercury. And it's no problem to convert this, right? Because we know that 760 millimeters of mercury is equal to 1 atmosphere. So we can just go ahead and say that 700, so that our pressure in atmosphere is going to be our pressure in millimeters of mercury, 774, divided by 760. Right? Because this is going to be 774 millimeters of mercury over 760 millimeters of mercury per 1 atmosphere. And even the way I'm going to do this when I calculate this out, I'm actually going to move this 760 to the top of our fraction, because dividing by 774 over 760 is going to be the same thing as if, actually, you know what, here, I'm just going to go ahead and hopefully I'm not confusing you. I'm just going to, this is hopefully just, you can see that this is just algebra. I'm just going to I'm going to multiply by 760 rather than divide by it twice. So anyway, we've got everything set up in our equation to go ahead and figure this out. And I'll actually give myself a little bit more space. And now I'll grab the calculator. So we are going to say that, so we have 760 times 0.678 times 0.08206 0.8206 times 305 equals, and then we're going to divide that by 0.450, and then divide it again by 774. And we get 37.027. So this is going to be our molar mass. Our molar mass is going to be 32.0, and how many significant figures do we have? It looks like, well, we had 3, I guess that's kind of ambiguous, but I think that was 3. 3, and, well, we had unequivocally 2 here, so we're going to report this to 2 significant figures, which we can just say is going to be 32 grams per mole. And that is going to be the molar mass of this gas that we are trying to find. So anyway, hopefully hopefully you found this useful, and in the next bunch of videos I'll just keep doing examples. Thanks for watching.